Welcome to Tech Packs. In today's video, we're exploring a cutting-edge AI-driven solution for parking management. Introducing the AI-driven space detection system using computer vision, a real-time parking space detection system that leverages advanced computer vision techniques to monitor and manage parking slots efficiently. This project showcases how AI can revolutionize parking management by accurately detecting occupancy in dual lanes, offering a smart and effective way to optimizing space in various parking areas. Let's see the demonstration of our advanced car parking system. This system efficiently manages parking slots using real-time video feed analysis and displays critical information on a GUI, making it easier to monitor and manage parking spaces. Let's take a look at the GUI. The interface is divided into two main sections, Parking 1 and Parking 2. Each parking area contains 10 slots, clearly labeled on the screen. Below the slots, you'll find additional information, including the total parking space available and the nearby slot available near the entry gate for both Parking 1 and Parking 2. We'll begin by parking a car in slot 2 of Parking 2. As you can see on the screen, the system detects the vehicle and updates the GUI, marking slot 2 as occupied. The information below now shows that nearby slot available is slot 1. Next, we park a car in slot 1 of Parking 2. As you can see on the screen, the system detects the vehicle and updates the GUI, marking slot 1 as occupied. The information below now shows that nearby slot available is slot 3. Next, we park a car in slot 4 of Parking 2. As you can see on the screen, the system detects the vehicle and updates the GUI, marking slot 4 as occupied. The information below now shows that nearby slot available is slot 3. Next, we park a car in slot 3 of Parking 2. As you can see on the screen, the system detects the vehicle and updates the GUI, marking slot 3 as occupied. The information below now shows that nearby slot available is slot 5. Moving over to Parking 1, we'll follow the same process. A car is parked in slot 1, and the system marks it as occupied while showing slot 2 as the nearby available slot. We continue to fill slots 2 and 4, with the GUI updating in real time, ensuring that the parking process is seamless and intuitive. Finally, we'll continue to park cars until all slots in both Parking 1 and Parking 2 are fully occupied. Once the last car is parked, observe the GUI as it updates to show that parking is full. This notification clearly indicates that no further vehicles can be accommodated, ensuring optimal use of parking space. This demonstration highlights the efficiency and user-friendliness of the car parking system. By integrating camera feed analysis with a responsive GUI, the system ensures that parking management is straightforward and effective. The real-time updates, slot availability information, and full capacity alerts all contribute to a seamless parking experience. Now, let's dive into the programming that brings the AI-driven space detection system to life. The mouse-click slot 1 and mouse-click slot 2 functions handle mouse interactions for managing parking slots in two different areas. When the left mouse button is clicked, mouse-click slot 1 and mouse-click slot 2 add a new parking slot position at the clicked coordinates and save the updated list to a file. If the right mouse button is clicked, these functions check if the click is within an existing slot's boundaries. If it is, the function removes the slot from the list and updates the file. The check parking space function plays a crucial role in analyzing the parking slot's occupancy. The check nearest slot function identifies the nearest available parking slot by iterating through the list of parking statuses and returning the index of the first available slot marked as true. If no slots are available, it returns 0. Finally, the display parking slots function captures video frames from the webcam and processes them to check the status of parking slots in two sections of the frame. It splits the frame into two parts, analyzes each for available parking spaces using the check parking space function, and displays this information, including the nearest available slot, in a status box at the bottom of the image. This function runs in a separate thread to ensure smooth operation and continuous video processing. In conclusion, The AI-driven space detection system offers a powerful and automated solution for modern parking management. By leveraging advanced computer vision and real-time video processing, it optimizes space utilization and enhances the overall parking experience. If you found this project insightful, please like, share, and subscribe to TechPacks for more innovative projects. Visit our website to purchase the complete package. Browse, select items, and click on Buy Now. Fill the required fields, then securely proceed to checkout, and you're ready to begin your project journey. Explore our site now to get started. Thank you for watching, and stay tuned for more exciting content from TechPacks.